Hello everyone! In this video, we are going to perform a deep dive into transformer vector groups. The vector group represents the phase displacement between the line voltages of the primary and secondary sides. This is primarily determined by the winding connections, star, delta, or zigzag. Let us begin with the star-star or Y-Y connection. The voltage vectors of each winding on the primary and secondary sides are in phase. However, the corresponding line voltage vectors on each side may be different, depending on the winding connection. In the illustration, the voltage vectors of each winding are shown in red, yellow, and blue. Here, the magnitude of the vectors is not important. The focus is solely on their phase relationship. The line voltages are also illustrated and are represented by the green, orange, and purple vectors. Now, regarding the vector groups for YY, if both sides are star and wound in the same direction, we get YY0. Adding a neutral gives us YYN0. If the secondary windings are reversed, the vectors shift by 180 degrees, resulting in YYN6. This group is rare and used only in very specific applications. Although care must be exercised when using YY connection, it has inherent advantages. First, the primary and secondary circuits are in phase. Second, since the phase to neutral voltage is only 57.7% of the line voltage, the windings require fewer turns to produce the same excitation level. Third, if the neutral is grounded, we can use reduced insulation at that end, which is a significant cost saver. You must be aware of the limitations of the YY connection. 1. Third harmonics at an ungrounded neutral can cause overvoltages at light loads. 2. Large voltage drops occur under unbalanced loads. 3. In some cases, it can cause severe tank overheating, potentially destroying the transformer. 4. It is prone to ferroresonance between the magnetizing reactance and line capacitance. 5. If a phase to ground fault occurs on a grounded primary, the voltage on unfaulted phases can jump to 173% of the normal voltage. Now, let us move to YD and DY connections. Adding a delta winding eliminates most YY drawbacks. The primary advantage is harmonic suppression. Since third harmonic currents are zero sequence, they circulate inside the delta loop and do not escape to the grid. Also, the zero-sequence impedance looks infinite from the star side. Another benefit is ground current isolation. A fault on the secondary side will not affect the ground protection on the primary side, which is vital for system coordination. In vector group YD11, the secondary leads the primary by 30 degrees. It has a lower inrush current than the DYN type, perfect for power plants and transmission substations. Vector group YD1 is similar, but the secondary lags by 30 degrees. The choice between 11 and 1 depends entirely on matching the existing transformers in your network for parallel operation. Next, the delta-delta connection. This setup suppresses third harmonics and handles unbalanced loads perfectly. If one single-phase unit in a bank fails, it can continue in open delta at 58% capacity. Being a DD0 group, it has no phase displacement, making it easy to parallel. It is commonly used in low-voltage industrial systems that do not need a neutral. However, DD requires more insulation since the phase voltage equals the line voltage. It also lacks a neutral point, making it unsuitable for four-wire distribution unless a grounding transformer is added. The DY connection shares the same harmonic benefits as YD. DYN1 is highly resistant to unbalanced loads and is used in regions where a 30-degree lag is the standard. DYN7 is usually used for interconnecting systems between different countries or power islands with heavy phase lags. DYN5 is found in older networks. Along with DYN11, these are the global standards. The king of distribution is DYN11. This is the most popular distribution transformer in the world. It is the IEC standard for urban and industrial substations. It allows for simultaneous three-phase and single-phase loads while keeping the voltage clean and stable. Finally, the zigzag connection. Zigzag transformers provide cost-effective grounding. DZN0 is excellent against extreme unbalance with very low zero-sequence impedance. It is the go-to for grounding transformers. DZN2 provides a 60-degree shift. This is non-standard but useful in rectifier transformers to reduce DC ripple. DZN1 and DZN11 are premium alternatives to DYN. They perform better against asymmetry and internal harmonics, making them ideal for sensitive data centers or large UPS systems. In conclusion, vector groups come from the connection type and winding polarity. Delta always traps the third harmonic. Zigzag ensures a stable neutral. Star provides a neutral for single-phase use. Parallel operation is forbidden for transformers of different groups. And always remember, DYN11 is the market leader for a reason.